All right, so this time I would like to start talking about sensors. And sensors are one of the things that makes a robot a robot. Um, the kind of the difference between a robot and a machine, or even a computer, is a couple of things. So first off, robots by definition have some method of moving in the physical world. Another thing that they have are sensor systems, and sensor systems are just ways for the robot to get information about what is in the world around it. And so far, the only sensor that we've actually been using is a rotational sensor that's inside of the motor. And that's how we've been telling it to go a certain number of rotations and stop there. That is the method. That's the only sensor we've used, is a sensor that's inside the motors. This time we're going to start taking a look at the ultrasonic sensor, which is this sensor on the front of the robot here that looks like a pair of eyes, sort of. And it works. I briefly go over it. They're not actually eyes. One of them is a microphone, and the other one is a speaker. So what it does is it sends a blast of sound out that is ultrasonic. It's higher than the human ear can hear. And then that bounces off an object and is received by the other eye of the robot. And the robot calculates the time that it took for that to happen. And by doing that, it can determine the distance away from an object. I won't go any deeper than that. This is the same way that like bats like find prey in the air. It's extremely similar to the way that sonar works for submarines. But that's not important. What is important today is that you understand that everything that has to do with sensors is numbers. Well, let me show you what I mean by that. So I'm going to go into port view on this robot so that we can see live what the sensors are doing. To do that, first I'm going to connect to the robot in my programming there. Now I'm going to go ahead and maximize the VRT here by pressing that button so we can just talk about what's going on here. All right, so I'm going to drive the robot a little bit closer to the wall. To do that, I need to start the simulator manually, and you can do that by hitting the play button in the hidden menu right here. All right, so I'm driving this robot, which is a little bit slow, so hang with me, over closer to this big blank wall so that I don't have to worry about objects being in my way while I... hey, look, we're vacuuming up a couple objects here. All right. So now in this menu here, I'm going to navigate over to this third section here by pressing right twice. And that will give me the first option, port view. This is an extremely valuable view. It shows you what all the different sensor systems are doing and which port they're attached to. So these robots have 4 ports for sensors, 1, 2, 3, and 4. That doesn't include the rotational sensors. They exist as well. But in this virtual robotics world, we don't actually take a cable and move it from the ultrasonic sensor to the back of the robot. But with a physical robot, you would plug in something here. It looks kind of like an old-timey telephone cable into the correct port. So right now we have sort of an imaginary one that is plugged into port 4, which is why this is on the 4th of these, right? And it is giving us results. The results that it gives us back is the number of centimeters that whatever it is seeing in front of it is. So where we are right now, it's seeing a distance of about 160 centimeters. As I get closer, you'll see that number drop. Right, so it's just the number of centimeters. That's all that you have to think about this as being, is the number of centimeters. And because it's numbers, that means that we can use it with the computer, with the central processing unit or the brain of the robot, in order to help it make decisions. So I'm going to show you how to do that. Let's go back to where we can start a program. All right, so we talked about exiting loops a bit. And what I'm going to do this time is I'm going to make a different way of exiting the loop. I'm going to tell this robot to drive. So drive. There we go. I talked about the on mode. This is a great example of why on mode matters. Maybe I will show what happens if you mess this up too, actually. Okay, so I'm going to tell the motor to turn on, and now I'm going to change the end value. I'm going to click on unlimited, and now I'm going to go down to the ultrasonic sensor. Remember, that's what we are looking for. So I'm going to measure the distance in centimeters, right? Now, I can just leave it where it is right now. So what this means is this loop will exit when the number that's in this right here, when this number becomes less than 50, it will stop this loop and end it. So this loop, just as it is right now, with this one block on the inside of it, is going to make our robot basically avoid hitting the wall. So let's take a look at that. All right, so the robot's moving forward and it's getting closer and closer to the wall. Maybe I should have picked a faster robot to do this, but we'll be patient here. So it's constantly looking, constantly updating with this sensor right here. And when it gets close enough to the wall, it stops. It doesn't hit the wall. It exited the loop. So that is one way, like the easiest way in my opinion, to get your sensor data to do something useful for you. So now you can do something else with this loop. So let's say that we want the robot to drive forward and not hit the wall. Then we can think, what do we want it to do next? What if we told the robot, okay, we know that you're next to a wall, so why don't you turn left 0.7, right? And if I ran just that piece, the robot would turn like that. And I'm going to add another loop. So watch closely. So imagine, well, let's talk about it first. Imagine if I have this set of instructions. Let's think about what the robot's going to do. It's going to drive towards a wall. And when it gets close to a wall, it's going to stop. And which way did I say, left or right? Let's see here. I said left. So then it's going to turn to the left. Then it's going to start over again because I'm going to put this loop inside of a loop. It's going to drive forward until it sees a wall. It's going to stop and turn left. Here, it's already close, so it's going to stop and turn left. All right, so the way that we do that is by putting this set of instructions inside of its own loop, right? So I'm going to grab another loop. I'm going to grab both of these instructions. I'm going to put this loop inside of that loop. And this is what I was just describing. The software is going to drive this robot forward until it sees something close to it. Then it's going to turn left. Then it's going to start over again. It's going to drive the robot forward. And let's see what that looks like. And our distance is 50 centimeters here. All right. Oh, I should have started it a little closer to the wall, but here we go. So the robot's going to go forward. Something to note about this robot is that it drifts a little bit left and right. That's because it's not a perfect build. A physical version of this robot would also probably drift a little bit, like not go perfectly straight. All right. So as the robot approaches the wall, remember that it's constantly looking through that sensor. Each time it goes through the loop, it's constantly looking at that sensor. Then it stops and turns, and stops and turns, and stops and turns. Right? This robot is going to basically attempt to avoid hitting objects. And so we call this kind of algorithm an object avoidance algorithm. And it is used on some different types of robots that need to avoid bumping into things or need to get into places. Like right here, it's going to be successful going under the bed. So this is a way that you can program a robot to not bump into the wall, not get stuck, in other words, which I hope will help you build more effective vacuum robots for your exploration of this board. You can see the robot working down here underneath. It's certainly not the world's best object avoidance algorithm. There's a lot going on that you could change here, but I wanted to show you how just the basic instructions that you have so far could lead you to object avoidance algorithms. Also, this this nested loop or loop within a loop here, it's a good way of seeing how that works as well. So I hope you find this useful and interesting, and we'll start talking about some other ways to use sensors next time. So until then, have fun and happy coding.